Greetings, everybody. You're here at Cyberhuman Frontiers with us, and we are so glad. Our continuing exploration into the brave new world of the future on all fronts. The biological, the technological, even the spiritual from time to time. So we're going to get our little community guidelines notices out of the way real fast and then get into it. Our videos do not claim to give medical, legal, political, or financial advice. We offer them for your entertainment. The points of view and purpose of this video is not to incite fear or violence, harass, bully, or anything like that, but to share opinions and thoughts with other like-minded individuals curious about the subject, to encourage conversation and awareness. The opinions expressed here belong to the people expressing them and are not a representation of the channel. We may, from time to time, incorporate certain copyrighted works into the show, not specifically authorized, are protected by federal law and the Fair Use Doctrine for one or more reasons noted in the Copyright Act of 1976. We are starting on we're continuing on the general exploration, but we're starting on a little bit of a review here initially of sizes, macroscopic, microscopic, nanoscopic. What does this stuff mean? How does it all come together in terms of bringing certain associated technological disciplines all to bear? Before I get into that, just want to say hi to TMC. How are you tonight out there?
I'm good.
Okay. So last week I started a little dissertation on this business of the biological creature, the human being. And I just wanted to touch on it again from this standpoint. We learn things, we process them in our minds, we come to believe that we know certain things, and how we arrive at that can be a few different ways. Thought processes occur, creativity occurs, but I wanted to focus just briefly, real briefly, on the idea that we get so much input from 5 senses, and those senses are very limited. Now, if the only way that we could ever know our world was by way of that input, and if those inputs being taste, touch, sound, sight, smell, all that stuff, if those were in any way hijacked or intercepted, and if that was the only way that we were getting whatever it is that we think and come to believe that we know our world, our environment, and everything that's real to us, well, then that would cause quite an alteration in the way that we see things, wouldn't it? One of the things that's possible with the really, really very precise and very advanced virtualization is the possibility that if a connection is established with a brain, then if those inputs that we have come to know our world by are substituted, well, then we're all of a sudden debased from reality. Now it's the reality of whatever's being put into our minds. Now, if it's valid sensory input based on tangible, concrete evidence of what there is right out there, now you've got something real. It would really do us a lot of good to contemplate how we arrive at our mind's reality. Anyway, continuing forward here, we're going to start off with a little bit of review of what we talked about last week. And I'm going to put a picture up on the screen. And we're going to go pretty fast because we have, as always, we have a whole lot to get to. And let's see if I got the thing here set right. Yeah, it looks like it's right. So, all right. Remember, our general discussion tonight here is macro, micro, and nano. When we look at this stuff, we're looking at something that is nano. And we're going to go a little bit further in some really nifty pictures of this and some experimental work and research that's been done. This stuff that you see is a unique 6-sided structure of carbon called graphene. And you can go and check out last week's show to get into that in further detail. So, review number 1. Review number 2. After these guys have made graphene and they've made graphene oxide, they've found that they can actually use it, those little holes in it, as a kind of a filtering medium. And because I'm going to get everybody dizzy with flashing between screens, but because this is atomic sized, those holes are actually really small. So it would enable the filtering and the gatekeeping of some really tiny molecules. And it's just a really interesting thing about it. There are experimental processes seem to suggest that it's not very difficult to make graphene. They're making it all the time in labs and doing all sorts of experiments with it. So this was one of the applications. And then let's move on to, now we don't have time for that. I'm going to go to a little video next, but one thing that I wanted to mention by way of general announcements is we have a new idea. We are now going to suggest the sci-fi piece of media of the week. Why? Because science fiction really does seem to come true. And so we have a team of people that are working to select something that's probably going to be slightly related to what we're talking about, and it'll be science fiction. And you know what? You just might find in a few weeks, a few months, or a few years that something that you watched that seems so wild and crazy came true. And you'll find this week's suggestion in the show notes below the video. Check it out at your leisure and enjoy. Remember, we said this is for entertainment. We're here to entertain you and help us all learn and discover at the same time. So first, we have what would seem like an unlikely content creator for this, but it's going to be interesting to you. This is from a YouTube channel called Alpine Security, and it's going to be food for thought. And I'm going to back it up a little bit here. It's really not very long. So I may pause it. We may comment. TMC, we can jump in on it if we'd like to here and expound or extrapolate. So here we go.
It may sound like a concept from a futuristic science novel or movie, but the truth is, it's not that far off. And it could be the next big cyber threat. How so? Keep watching and find out. Nanotech, a recap. Nanotechnology is any technological endeavor that deals with anything with a dimension of fewer than 100 nanometers. While the concept was first brought to light in the late 1950s, it wasn't until the late 1980s that technology advanced enough to actually allow scientists to work in such a small field. Nanotech.
Okay, this man is very soft-spoken, but his soft words carry a big punch. And this is a gentleman from Alpine Security. And I wish I could turn it up louder, but I can't. So here we go. Listen carefully.
Technology has several applications, including food, technology, fuels, batteries, environmental causes, chemical sensors, and even sporting goods. The medical field is one of the most exciting for nanotechnology at the moment, though most developments are still in the experimental phase. With these developments comes the ever-present technological risk of hacking. Nanotech in humans. Building new muscle with carbon nanotubes is one such possibility. Scientists at IBM are also working on using nanotechnology to analyze DNA in just minutes, instead of weeks, to treat cancer patients with a customized treatment plan. We're also seeing the use of nanotech in chemotherapy or vaccines to target specific types of cells in the body, where experimental nanosponges are being tested to absorb toxins in the body. Nanotech.
So, do you see what one, I'm sorry to interrupt this gentleman, do you see what one of the potential issues is? If the technology is moving forward in such a way that we're able to successfully and effectively de-weaponize cancer cells, if we're able to get that far in, and if at the same time the nanotechnology that enables us to wipe out cancer cells or fix, I don't know, maybe genetic errors or who knows what it is, the risk of someone using that to hack what otherwise was the correct code in a human being or in a mouse, if you will, is there. If you can get in and fix something, you could get in and break something.
Is also being explored as an early diagnostic tool to detect cancers and infectious diseases long before our current technology is able. Some ideas include a tiny device that gets injected into the body as a sensor or a medical delivery device. This all sounds positive, but there's a downside too. Is it secure? Tiny nano devices are typically controlled by a program on a traditional electronic device like a computer, smartphone, or server, meaning they could be very hackable. Some digital security experts posit that a single nanoparticle.
We've covered in detail some of the technology in some of those smart devices we've actually shown how they have demonstrated that ability to interconnect with an organism or a part of it.
In the body with its own processor could be hacked. But they also say that if someone had more than one particle in the body, which many treatments would require, a hacker could theoretically turn them into a network in the body, using the body's own systems to communicate and do their bidding. One of the most obvious and dangerous applications for biomedical hacking is ransomware. If a hacker took over your inner nanotechnology devices, they could demand a ransom with fatal consequences.
We discussed a little bit about graphene lace and a matrix of graphene, which can be made to be electromagnetically sensitive and electrically conductive as well. And so, if you've got that there, and now somebody gets in and starts utilizing it or commandeering it for the purpose of either monitoring or sending signals, well, there could be a potential invasion of privacy and a possible takeover of what would be the organism's otherwise autonomous processes.
They could easily turn your body against you, and at the very least make you suffer or get sick, if not kill you. It may also be possible for unsavory characters to use nanotechnology itself against their enemies, not only in hacking attacks such as inhalable particulate powders to treat lungs. Some worry this technology could be an easily weaponized delivery method for bioterrorism efforts beyond the hacking dangers. Getting infected with something could be as simple as breathing the air, taking a shower, or getting a regular vaccination from your doctor. Mitigating the risks. The most powerful thing that needs to happen to lessen the risk of hacking with nanotechnology is legislation to regulate the types and strength of security required on nanomedical devices, and even the function of devices that will be allowed. Medical device manufacturers who wish to ensure that their devices are not likely to get hacked should do proper penetration testing. Though this area is still in its infancy, we can use the term nanomedical technology, nanomedical hacking, and others that truly describe what it is until something else comes along. The term biohacking sounds like the perfect term to describe hacking medical technology, but it actually refers to do-it-yourself biology. This is a self-improvement technique that uses diet, exercise, and mental techniques to hack the body to improve mood, health, and overall life satisfaction. Neobiology may suffice, as it generally refers to any new advance in biological technology. Nanotechnology and medical device hacking would certainly fall under this umbrella, but the umbrella is very large. Lastly, it could also fall under the Internet of Things label, but this is a broad term, so it doesn't exactly define it. Risk realism. Has there been a true case of medical device hacking? The answer at this point is not clear, but there have certainly been crippling hacks of medical centers. At this point, the risk seems to be mostly theoretical, though it's just a matter of time before black hat hackers pick up on what white hat hackers have been researching and trying to prevent.
Exactly right. Do you ever really know? I mean, right now, with, let's say, our outboard devices, the computers that I'm looking at right now, or our smartphones, if there is or is not some sort of subtle, buried in the code spyware in it. Do you know that? The operating systems that I'm using have become so sophisticated that do so many things behind the scenes that I can't know for sure whether they are doing things that are on my behalf or not on my behalf. That's the first thing. Second thing is, at what point does something turn from just being observationware or spyware into some sort of controlware? And do I know, do we really have the facilities and do we have the time and do we have the lab equipment to really analyze exactly what this software is doing in that piece of technology that we're using? And the answer to that is pretty obvious. We don't. We aren't going to know. And not only would we have to dedicate, the efforts of someone at the level of a computer scientist to it, but now there'd be the biological aspect of it also. So it's really, if you really look at it, it's really kind of darn scary.
Some experts believe it's only a matter of time before something fatal happens involving the hacking of a medical device, and that only then will medical providers and legislators take this issue seriously. As mentioned before, penetration testing is one of the best ways to find vulnerabilities in medical devices and ensure that your products are as secure as possible. Alpine Security offers a full range of penetration testing, including in the medical field. If you'd like to be on this cutting-edge field of security and technology, inquire within on our site. And if you enjoyed this video, be sure to like, comment, and subscribe.
All right. Well, I guess we ended up inadvertently doing a little plug for Alpine Security. For the most part, I really like what he said. I think that he brings up the issues that are germane to the time that we are in now, and I have an extremely pessimistic view of it. Not Alpine Security. I have an extremely pessimistic view of our being able to maintain control over it, because if a group, a company, or an individual has to dedicate that kind of time to, coming up with mock exploits, to actually try to get into something that should be secure and do vulnerability testing and all that, well, that means that because we've opened the gateway to an area which can be exploited, now we have to dedicate a person, a whole lot of time, or a whole team of people to testing and retesting and always looking and being vigilant to try to task legislators to come up with some sort of rules and regulations for it. TMC, what thoughts do you have there? I mean, this is like chasing a racing freight train that has been put on a track that was built to a destination that it might not be wise to go there.
I think the ship has sailed already. This is already so immersive, so to speak. So whatever that means to you, what does immersive look like when you start talking about nanotechnology and the variety of ways that it can be deployed and dispersed throughout the environment to then at a later time do something similar to functioning like construction materials and then as different types of antennas or transducers inside of biologicals or inside a plant soil or in the packaging of food so that the stores know when to rotate stock or when something goes out of code. It's a whole new frontier as it relates to what can be distributed into the environment, as well as the complexity with which that distribution can then be manipulated once it's already deployed.
Well, all right. From the protective and the beneficial standpoint, how are you ever going to keep quantifying something that keeps developing and, goodness gracious, coming up with legislation to keep it under control when not everybody, well, not every company, not every group or organization obeys the law, okay? Some of them just do what they want until they get caught. I mean, I just don't see a way to secure it any better than we can secure anything else. Every once in a while, an exploit happens, whether it be the controls for a pipeline or whether it be security in, one of our military facilities, whatever it be, it happens from time to time. So I don't know. I think that it's just crazy. So I got this little thing right here, and to give a little bit of substance to some of these technologies and what really is going on. This is from Regen Health Solutions, and I'll put the link for this, of course, as you know. The title of this little article is The Magneuron Project, Remote Controlling Cells to Cure Neurodegenerative Diseases. But I want to stop the sentence right there. Because maybe you could.
If you're a Christian and you love guns and you're a Trump supporter, then the last half of that sentence applies, because you'd be curing a neurodegenerative disease that's commonly known, or at least being framed today, as white supremacy, which is completely it's completely like not applicable to what you're trying to catalog or categorize an average American these days, or an average freedom-loving global citizen, so to speak, because everybody really has the same fundamental desires, which is to function in an environment where they have some sense of autonomy and some ability to make their life better for themselves and their families, provided they put in the work.
Yeah. All right. Good points. All right. So I take this little part out, this to cure neurodegenerative diseases, because who's deciding what is a neurodegenerative disease? All that business. I just stop at remote controlling cells. And the one other little piece that I'll pick up there is neuro. So cells, neuro, we're talking neurological cells, we're talking brain cells. Okay, now I'm going to go.
A neurodegenerative disease could also be something like rheumatoid arthritis or something that relates in numbness of the limbs, or a misfunctioning of an organ system, or misfiring of a heart, or kidney failure. Any of these things can be a symptomology of some type of neurodegeneration, because the nervous system connects everything to everything else in your brain and your body.
That's right. That's right. Something that I didn't know, I may have repeated it at one point on a previous show, but in the heart, is we generally think of it as a muscle, but I found documentation that indicated that the heart actually has more neurological cells in it than it does muscle cells, and I was amazed to learn that. Just interesting. Yeah, little tangents that I go on. So anyway, I'm just going to read this little paragraph here. You know, if you're kind of skeptical about this, this is all on the backdrop that I think that we're getting into a territory that's going to be impossible to control. And I think that a track is being built for a destination of a racing freight train that is to a destination where it probably should not be going. Not because it couldn't be wonderful, but because it's going to be impossible to control nefarious forces from getting in there and exploiting and hijacking. It's going to be impossible. And if you think that they're ever going to be able to legislate enough to do it, there's no way. There's no way. Anyway, let me read this little paragraph here. We won't read the whole thing. It's pretty good, and you'll be able to read it all to your complete satisfaction at the conclusion of the show. How can we control cells in a human body? We need a form of remote control to tell them what to do and where to go. Some years ago, we had the idea of using magnetic nanoparticles and magnets, rather like how children use magnets below a sheet of paper to move magnetic objects as if by magic. And that's a really good analogy. We thought, why not do the same thing, but do it within cells? Well, okay, if you wanted to do it within cells, then you'd substitute the piece of paper for the cell membrane, and you would substitute the large magnet for a very small magnetically energizable piece. And then you would use another magnet to steer that magnet that you've put inside that cell wall. And it's really just a matter of miniaturizing it and coming up with the appropriate compounds to be able to get into the organism so that they won't be attacked by the immune system and get eliminated. Yeah, TMC.
Yeah, so if you had something that was magnetic, could you theoretically maybe put the biological organism in a magnetic field that's a variable magnetic field, or even a field biased DC magnetic field, which can be done with AC electromagnetic transmission systems? Would that kind of also work in this scenario where you have something that's magnetic in a body that would then respond to a particular orientation of a magnetic field, being a variable field or a static field that's remotely delivered?
The answer is yes, with a capital Y.
Oh.
And a capital E. And a capital S. Absolutely. And for not everybody's an engineer. What you mean by a biased static field is you apply an alternating electromagnetic to something that is otherwise just an established magnetic field. And by doing that, you can alter the characteristics of what that static magnetic field would do by way of the electromagnetic input. So it skews it. It skews it. And it's more effective than just using the electromagnetic field alone, because if you've got some ambient magnetism already there, then you can steer it. You steer that magnetism. You don't need to supply all the magnetism. You know what I mean?
Let's break that down. Let's break that down. Okay. So you can create a biased electromagnetic field with a standard multi-antenna transmitter, just that all by itself.
Yep.
What you're getting at, Indy, is something like Wi-Fi and cell phone transmissions in a house, right?
Exactly. Exactly
have
right.
wiring in the walls that then have their own 60 hertz alternating magnetic field. So if you know that you have a 60 hertz alternating magnetic field in all of your walls, which you can then map the wiring based on the field strength, the field density of the electromagnetic fields that are being emitted off the wires in your walls, you can then introduce pulsed electromagnetic radiation into the environment that, when transmitted in a proper modulation, interacts with the 60 hertz alternating electromagnetic fields that are interacting with themselves in said four walls, ceilings, etc.
Exactly.
So when you have smart meters that
and that's just
are connected
one
to the internet that
that's
tie
just
in your
one
power
thing.
lines, and you
That's
have
just
cell phones,
that's just the 60 cycles. There's other interactions that are also in our environment.
You also have the plasma that's created from compact fluorescence. You have LEDs that are their own electromagnetic transmitters that all offer an opportunity for complex harmonic wave interference that really is a translation between what is understood as photons and phonons, which are just the smallest measurable amount of a sound wave, a longitudinal wave. And when you start looking at force conversions with things like radiation pressure and longitudinal wave pressure and how these things interact, especially when you introduce things like thermodynamics or fluid dynamics or other types of unique environmental characteristics that exist around us and or within our bodies, you can create some very, very sophisticated interactions in the body that go beyond just magnetic interactions.
And you really need to pay attention to those other dynamics, because if you're not and you're trying to get a desired result, then they can be undermined by those other factors. However, if you've understood them and if you then use them as part of the overall control process, then the chemical dynamics or the thermodynamics can actually enhance what it is that you're trying to do. And we've covered research in all aspects of this whole area. And yes, we were talking about an Etch-a-Sketch. That was last week, I think, or 2 weeks ago. But
so the real benefit to studying one of these opportunities to access the human, right, is it's great to look at one particular aspect. But when you look at what it's ultimately trying to do, which is a remote interaction, read and write, and then you look at other ways that the biological organism that we understand as a human, right, when we understand exactly how other things like thermodynamics, for example, interact with the human, what you can do is start administering small amounts of a variety of different things that interact with the biological organism, which takes you out of the thermal and out of the harmful government regulated standards and puts you well within within government regulations to transmit a variety of things into an organism that's all controlled with software and AI to ultimately create a manipulation and then measure the manipulation and then offer subsequent manipulations and subsequent measurements to ultimately automate something, some function, even if it's a medical procedure, even if it's a medical procedure to fix cancer or to artificially beat a heart instead of an old school pacemaker. A lot of positive applications exist with this technology, but it's a dual use technology, which means that there are a lot of potentially harmful applications that exist and in my view are already out there in the environment at this point.
Let me just translate it and then continue on. Yeah, absolutely. So we've got six environmental factors, each of which falls within safe, reviewed, laboratory tested limits, of course, on mice. And now you combine all six of these together. None of them violates the safe limits, but all together they potentiate each other and can create a profound and compelling alteration to the condition of an organism. And how hard would it be to figure out how that happened? Unless you wrote the master software that was controlling all of these factors all at once, unless you knew that, how would you even know what factor it was and how it worked that caused the alteration or the compromise? Go ahead.
the companies that would know are what we understand as big tech, but more importantly, the companies that would know are big telecom. And the reason why is because of multiplexing and information aggregation. To be able to take multiple points of connection and put them all together on a carrier channel and then transmit that from point A to point B and break it all back down into independent connections, just like the mail system would collect the mail and it would go to a mail center and it would go somewhere else and then it would go to a mail center and it get processed and sorted and out to a truck and off it goes into the mail. Well, information works the same way. And the telecom companies like AT&T, Verizon, Google's now in the business, Facebook's getting into the business. It's big tech and big telecom and this big incestuous, perverted raping of the species, if you will. And in my view, it is the telecom companies that ultimately possess software and hardware currently deployed to do things like sniff out pedophile behavior online. That stuff is written into the FCC Internet Bill of Rights banter that goes back and forth as it relates to how we're going to apply the Internet Bill of Rights to something like the internet. And big telecom are the main providers, the main lobbyists to the FCC as it relates to the transmission and reception of electromagnetics, the issuance of licensure for the transmission and reception of electromagnetics, what's harmful, what's not harmful, and what's allowable to be transmitted over the internet, and who's responsible for that transmission. So here's where nobody gets in trouble because everybody has a piece of the pie. If you have edge providers like Facebook and Twitter and Apple and Google and Amazon at this point, right, which is now a hybrid, same thing with Microsoft, being in one category of their own, and you have telecom being in another category of their own, because everybody needs an internet connection for whatever it is they're doing. You have a group, a conglomerate, if you will, that work together to share the risks, liabilities, and benefits. And if you have the right people circulating around in the boards, if you have the right people circulating around the boards of these companies throughout a 30 or a 40-year period where they have mentors and they become mentors and then they hand off whatever it is the long-term strategies are at groups that come up with this stuff, like the Tavistock Institute and the CFR and the Atlantic Council and the Bilderberg Group and Davos and the pig Latin guy over there, what's his name? Klaus Schwab.
Can I say something? Can I say something? They're distributing and diffusing the risk. And at the end of the day, if all that we have is legislators, the current state of affairs in our legislative bodies to depend on legislators and bureaucrats to come up with something that encompasses an understanding of all of this diffused and distributed risk so that it's very hard to pin it on any particular one organization or body is about as utterly fruitless and will be as completely impotent in its ability to provide protections as anything I could possibly think of.
Cyber Command and Space Force and the NSA at this point are the cyber line of defense to whatever it is that's going on. And I hearken back to Cheyenne Mountain and it going into lockdown back in March of 2019, I believe. 2020, something like that, whenever they declared the pandemic. And I think it was 2020. Okay. So Cybercom and NORAD and Cheyenne Mountain all went into lockdown, and I don't even know if they came out yet. I have no idea if they're still in there, but as a result of it being a pandemic, they were worried about continuity of the military and or continuity of government. Therefore, they did some interesting stuff. Simultaneously, what they did was launch a brand new satellite system for the Air Force / DARPA, which is the Advanced Extremely High Frequency Satellite Array, which consisted of approximately 6 satellites that they are telling the public about. That is paired with DARPA's Blackjack program, which is basically the first version that they're publicly going to announce as a modified Skynet, which is where satellite systems can be put up into space and they can function autonomously without any ground-based stimuli for what they say 21 days to 30 days. And that's just the basic program parameters for companies like Boeing, Lockheed Martin, Northrop Grumman, etc. And the point of that program is to be able to run internet networks for the military and for critical infrastructure in the event of grid down, like, oh crap, grid down, really, really bad war kind of stuff. And what these satellites do is they go in and they hijack other satellites so that they can take over command and control of grid transmitting infrastructure down to Earth to maintain internet connectivity for complex AI-driven military and civilian functionality. So these are redundancies that are going up into space that exist terrestrially that were redundancies for what was put up in space, in my view, during the Kennedy-Reagan era, where you had Russia and China and Iran and other countries all getting in on this, but the space race was really between Russia, America, and likely others who bought in as, I don't know what you call them, sidecars or whatever. So all that said, I know I digressed a lot. The bottom line is that the internet providers are blurring the lines between who has control over network traffic.
Yes.
And if you're going to regulate internet driving software that ultimately provides a read and a write mechanism to a human organism through something like a cell phone, all you need is Cyber Command to regulate the internet with software. I mean, the cyber war is all done with software. Go ahead, Indy.
Let's say you ultimately wanted to always make sure that you, as the overlord of this whole plan, always wanted to remain above regulation. What would you do? You'd obfuscate it. You'd make it nebulous. You would distribute it so that, right?
Yeah, it has to be done that way. If
right.
you have there's going to be competing AI systems, and one system is a Chinese model, and another system is going to be a Chinese model that has a distributed model that looks like what I think people are going to be sold as a real, true, and free distributed architecture for the internet, even though it won't be. And then there'll be another Chinese style model on top of that that really kind of functions in the background through a modified global government. And that's really the problem with all of this is however the de-escalation, if we go that route, goes, armistice, whatever it is, there's still going to be, just as you said, Indy, the watchers who are watching the watchers. So who watches the watchers, and how do you distribute architecture so that the watchers ultimately default to devolving power back to the common man, so that the common man has equal tool sets to combat an authoritative government? And that is the fundamental underpinning of the American project.
We don't have an equal tool set now. Right now.
Okay, I agree with you. Everybody, make sure you have ample supplies of duct tape and sandpaper, because whoever's coming to your doors after the vaccines and the rifles are probably going to want to use those things, and they may not have enough from their little party as they go up the road, going house to house, picking and plundering whatever they want because everybody's pissed themselves over speech.
Goodness gracious. It's a brave new world. I had a thought, which was so much of what we see is something that's been put there for us to see. We would be well served to develop a skill. It almost sounds kind of far-fetched, but rather than an ability to digest and consume what is put there in front of us to be consumed, we'd be better off to come up with a skill of seeing the invisible, if you know what I'm getting at. Seeing everything, extrapolating, connecting dots. You're never going to be able to prove all of it until, by the time you can prove any of it, it usually will have been too late unless you had already connected the dots ahead of time.
Look at what's on the screen right now.
Yeah, exactly.
We're talking about magnetically manipulating organisms remotely.
Right.
So the reason why I think we're blinded is because we're accustomed to 70% of our stimuli coming through our eyes, and then a larger majority of what's left over coming through our ears. And that's how we've been accustomed or acclimated. So when you think about what that does when it forms neural circuits in the brain, you are searching and seeking for things that only your eyes and ears can hear.
Conditioning.
Right, which are the very systems in the brain that allow for something like magnetic nanotech to artificially stimulate centers in the nervous system that talk to the parts of the brain that function as the visual center and the audio center without using thermodynamics with something like thermoacoustics, which is a commonly known microwave acoustic effect that was discovered many, many years ago, also known as the Fry effect, that deals with sending pulsed microwaves to a brain, and the chamber, that is the head, functions as a resonance cavity that ultimately allows for rapid expansion and cooling of tissues that then stimulate the nerves, ultimately yielding a modulated signal to the audio centers in the brain that we understand as microwave acoustic speech.
You hear it as
this is just an evolution of that, where much, much less energy can be applied to an organism and perform the same functions, like activating the audio centers, the visual centers in the brain with something like magnetic spin rather than thermoacoustics.
Yep. And, to my view, it's already been quite elementary to be able to program human thought and minds and condition people already, without even applying these advanced technologies. It was already easy to control the way people think, wasn't it? Now look. I'll read some more. Okay, so these guys are all excited about the, I'll put it up on the screen here, the Magneron project. But let me finish reading this paragraph. Much the way children use magnets below the sheet of paper. That's how it started. Okay. There were several challenges on the way. First, they needed to know whether or not they could move magnetic nanoparticles inside cells. Well, apparently they decided to go to work in the laboratories to figure out whether they could move magnetic nanoparticles inside cells. And in 2013, we did a proof of concept and showed that indeed we were able to do so. Lovely. Second, the magnetic nanoparticles had to provide instructions for the cells, telling them to grow or move in a specific direction. To do this, we thought of hijacking the signaling machinery of cells. I mean, if I had a highlight, I don't have a highlighter on this graphic program, but if I did, I'd be highlighting certain words. Cells coordinate their activities thanks to an incredibly complex molecular circuitry. Thousands of biochemical reactions, highly regulated in space and time, are taking place at any one time. And this is the creative genius of life. Okay, we're talking about hacking into the incredibly complex processes of thousands of biochemical reactions, which are the stock and trade of every living creature on Earth and plant. We decided to cover the surface of our magnetic nanoparticles with specific proteins that act as triggers for intracellular signaling. And you can readily understand what that means, because the specific proteins that they chose were going to be specific proteins that were integrated in some sort of a life or metabolic process. But they added on the protein, which will be recognizable and utilizable by the cell with the magnetic nanoparticle. So they combine the two together. They demonstrated this idea by forcing a cell to extend its body along an imposed direction. So what they're talking about there is they're talking about getting it to, under command and control, distort its shape into another shape of a cell, forcing its body, the cell membrane, to contort in a way that is being controlled by this input. The signaling protein that we attach to the magnetic nanoparticles was produced by the cell. Well, isn't that ironic? The protein itself was produced by the cell. Genetically encoded. Thus, we coined the term magnetogenetics for this novel technology, and that's something that we've discussed in previous episodes. So, moving on. They came up with another buzzword, the Magneron Project. In 2016, we decided to go yet one step further and try to apply our methodology as an innovative treatment for Parkinson's disease. We applied for and received funding, which enabled us to gather a consortium of 6 research teams from France, the UK, and Germany. The idea of the Magneron Project is to use magnetic nanoparticles to direct the growth of neurons' arms in the right directions. And those arms are going to be its wires, its extended way. A neuron has a body, and then it's got wires like tangent arms sticking out. Some of them are input arms, some of them are output arms. So, directing the growth of the neuron's arms in a direction once the engineered cells are implanted in the patient's brain. Like moving a piece of iron across a sheet of paper with a hidden magnet underneath the paper, the magnetic nanoparticles are accumulated on one side of the cell. Thanks to specific proteins attached to the surface of the nanoparticles, they induce a signaling cue that orients the growth of the cell. And you know what? This is great, and it's possibly a promising technology in the remediation of some of the severity of the symptoms of Parkinson's disease. It's also something that could be used for other purposes. I'm just saying. Okay. EU funding has had a profound impact on the project, acting as a formal accelerator of scientific progress. Instead of doing our own work and waiting for the rest of the scientific community to react to our findings, we now work in close collaboration with chemists, biophysicists, neurobiologists, Parkinson's specialists, and experts in cell therapy. And I think that pretty well covers the pithy contents that I wanted to get to here. Now that the technique we've devised is mature enough, remember they kind of did their proof of concept in 2013, and then they went to the stage 2 in 2016. Now that the technique is mature, we are moving on to real neurons and applying our method to living cells. Ultimately, we would like to perform a proof of concept using brain slices from rats. A challenging task, but very close to the situation we would like to find in a human's brain. There are still hard obstacles on the way, but we have a very innovative tool with great potential. We expect that magnetogenetics could be effective in treating Parkinson's disease in less than 10 years. And if you just back off from Parkinson's disease, they're talking about Parkinson's. Let's say we just pull out the general thrust of this, that is in controlling the formation of the arms of brain neurons with this technology. Well, those arms that interconnect brain cells, that's the wiring. That is the wiring that constitutes what behavior patterns are learned. That's the wiring that constitutes if A, then B. If I eat, then I digest. You know what I'm saying? You'd come up with a lot of other examples, and some of them border over into the psychological area of thought. The eyes. If I see food, I get hungry and I salivate and then I want to eat it. That's more sort of like psychological and behavioral and conditionally programmed, right? Or whatever. Or if I, whatever it might be. Okay, so anyway, that was that. Some of their mechanism was on this diagram, which is not all displaying, but I think I can fix that. This diagram is credit to
we never really talked about this diagram, do we? So remote control and differentiation of growth. So you can tag a specific neuron, and then you can, with the use of magnetic fields, pull the dendrites around,
right there,
which creates physical rewiring configurations. So if you were to modulate the nanomagnetic particles or the nanomagnetic prions that are now grown in there. And there's a patent I can dig up. I have it on my computer somewhere, and it talks about like Magnon or Magnero 2.0 or something like that. It's an actual patented thing that talks about genetically modifying cells so they're responsive to magnetic fields. And if you can use magnetic fields with magnetically responsive proteins or nanotech in the brain, you can start physically moving the wires around in the brain, the dendrites that function as the electrical circuitry around. So what you're talking about is not only a software manipulation as it relates to potentially remotely firing different centers of the brain simultaneously to get complex neural frequencies, EEG patterns to elicit. Not only can you do that, you can also physically manipulate the architecture of the brain to then be able to more specifically drive those complex electric fields into the places at the times that you want.
Right.
And what we're looking at here is a mechanization and a methodology
to wire brains.
Exactly right. And so if you have a single Godhead brain that is the model that then AI says as close as we can get all biological brains we can talk to on the internet to look like the Godhead brain, we can now send singular unified code, albeit maybe distributed and in different languages and contexts so that it looks like there is some sense of freedom. You still have a single Godhead that's up there running all this stuff, and that is wrong. It's wrong. It's wrong. But that's what we're building. That's what humans are building.
What we got to look at is the amount of potential good that can come out of this versus the amount of potential harm. We have to look at the benefits versus the liabilities, the assets and the detriments. Pick any words you want. And it just keeps adding up to me, from a whole lot of risk. What is beeping? Something's beeping here. It adds up to being a whole lot of risk. I think I found it. Yeah. So, where do you want to go next? I mean, this really sets the table for the most important discussion of, I don't know, of decades. All right. It really sets the table. We started off on that idea of how we think, and it implies that we still can think and that our thoughts are still our own, and that what we find to be any sensed condition is a genuine, not aliased sensed condition or input or whatever it might be. And if you're talking about being able to rewire something like this right here, these connections, this little thin line, let me zoom back in on it. Those little thin lines constitute our behaviors, our memories, our knowledge, our patterns, our skills, capabilities, capacities. This is how this nexus between one neuron and another one is what controls every single thing about our automatic bodily functions, our thoughts, our memory, everything, all of it. So if you can start taking control of this, then you can basically turn a mouse into a mouse that had a different personality from the one that it previously had before you started rewiring the mouse. And I guess just for entertainment purposes, let's just talk about rewiring a mouse or a rat.
Can you zoom out a little bit while we do that so we can see the old man with the arrow coming out of his butt?
Of course I can.
All right. So the hypothetical mouse, for your entertainment purposes only, go ahead.
This was as of 2019, by the way. So we're a couple of years ahead of this. Okay. Anyway, go on.
Mice who are hypothetically going to become drones. So go ahead.
Mm-hmm. Well, look at how it actually works. You have here the field of a magnet. Now, in reality, this is depicting a permanent magnet. All right. And for what they're doing here, they can actually use a permanent magnet if they're trying to get a single direction of movement of the wire coming out of one nerve cell into another one. All right, that's fine. But this is pretty generalized, and here's why. If you have what they're showing here, this is an oversimplified diagram, people. This is a horseshoe magnet. Simple. It's a static magnetic field. What we can do, and you know what I got to do is I got to find some good animations of wave interference and put it in the show notes so that you guys can look at it. And what you'll find if you look at wave table interference, whether it be in water or sand or anything, and you input varying magnetic field, varying fields of energy. Okay, now in this case, it's magnetic. In the case of the animations that I may find, it might be mechanical energy. Same thing. Doesn't matter if it's magnetic or mechanical. The patterns that you'll see formed will be very reminiscent of exactly what could be done with electromagnetics. And I do hope I find a good animation for you because I'm going to put it in the notes. Anyway, back to the central point. This is a simple static magnetic field created by a horseshoe magnet. This is not the way that this would be done if one wanted to find a very specific part in this person's brain and get the type of movement of just one isolated little part of that, of what they've infused into this person's brain, or into the mouse, into the mouse's brain, which was the magnetically sensitive protein-linked nanomagnetic particles. That's how they're making this thing grow in that direction. Now, imagine that you substitute, instead of a horseshoe magnet, you substitute an intelligently driven, software-controlled group of electromagnetic radiators. Now you're going to be able to get very specific targeted location, and you can pick, I don't know how precisely, but with a whole lot more precision than with a horseshoe magnet. You're going to be able to target particular areas of the brain and cause this axon and dendrite growth, and that's what these little branches are, in that very specific area.
How many hours do you sleep with a cell phone or two next to your bed? How many plugs are next to your nightstands? And how many things are you plugged into?
Right.
How many walls do you have in your room? And the ceiling counts as one. How many plug outlets and appliances and transmitters exist within a 30 to 50 foot radius of your body while you're lying there lifeless in bed having interesting dreams? Dreaming, exactly. And you're not moving. And so for a long period of time, your body can be imaged very, very, very slowly, which means that very, very old tech that has low resolution and potentially slow sample times has 6 to 8 hours while you're generally not moving more than 6 to 8 inches in any direction at a time. They're able to, with very low resolution, sample, and understand exactly what the specific characteristics are of your tissue, what the dielectric properties are, what the densities is, what the sizes are, what the orientations are. They could potentially map different things like what makes you twitch, at what voltage, field potential do your fingers twitch or your feet twitch, or you induce a calf contraction or a thigh contraction or a groin contraction. When you know all of these things, when someone's sleeping, nobody knows while they're dreaming what's happening.
And there's plenty of time. They've got all night to do this while you're sleeping. And there's more. Yeah. What also induces an elevated brainwave state or a reduced brainwave state? Then
and only then, when you're driving in your car, you get a spike protein stimulation and your foot happens to twitch because of the exact precise known table that was referenced through the AI cloud to ultimately have you apply the brake or the accelerator or steer your steering wheel to the left or the right with a joggle or a twitch as you're looking over your shoulder because somebody in the back seat maybe dropped their juice box and wham! We just had a totally innocuous accident with an automated vehicle and it's the human's fault. So now insurance rates go up because humans are the problem and automation is the ultimate final revolution and the technocratic solution, putting out proverbial pollution. Anyway, I'm done.
So think of it. Has anybody ever contemplated the idea, or maybe it's happened, that I can't remember the last time it happened to me, but did you, maybe you have, maybe you haven't, and I'm watching the people participating with us. Did you ever just conjecture about, why did I think that? Or why did I do that? Did you ever ask yourself, I have no idea why I just did that. This is not something that happens to me. Maybe it will. I hope it doesn't, because I don't want it to. But imagine moving into a world.
You know what that translates to?
Part of your what?
Alzheimer's, dementia, schizophrenia, some type of mental disorder that HARPA, which is now in full effect thanks to the new science czar that left the Broad Institute, and then Eric Schmidt decides to join or become a higher ranking member within the Broad Institute. He has his own foundation, which is linked directly to the Broad Institute, Eric Schmidt, I mean. And anyway, go ahead.
I would not be looking forward to a world in which many of us were walking around and then asking ourselves, why did I do that? Why did I think that? But things like this, if misapplied, or if the additional wiring is hacked into by some nefarious interest, whatever it might be, it could be that you might be asking yourself, why did I think that? Why did I do that? How did this happen that I just jammed on the brake? Why am I hearing a sound that there's no source for? Things like that.
You know what I'm thinking about right now?
I have no idea. What? Do you? I don't know.
Ion plasma grenades. You know what an ion plasma grenade is?
Are you going sci-fi on me here?
Well, you mentioned that earlier, that perhaps something out there might mention itself as it relates to the sci-fi field. So an ion plasma grenade may in fact be that. And what it metaphorically represents is this idea of multiphotonic ionization that can occur at the atomic level to manipulate something like protein folding up to and including, now that's the micro, right? Ion plasma grenade can potentially do something like induce an inflammatory response, and then liquefy an organ because of the response to the inflammation, right? So an ion plasma grenade could be something like multiphotonic applications to cells or tissues that then cause some morphological or epigenetic change that in and of itself elicits a change in acid, pH, elicits a change in heat, elicits a particular type of protein to be expressed, an endosome turning into an exosome that the body then understands as a trigger to potentially do something like induce an inflammatory response that results in the scaffolding of something like your brain going away, so it turns into a bloody liquid pulp. But I digress. Plasma grenades.
The idea. Well, one of the ideas is with some, not exactly specifically this one, but with associated technologies, the idea of being able to target and, if you will, liquefy carcinogenic cells to help cure cancer. But once again, if somebody hacked into it and they've got a technology that's able to be brought on board and liquefy cells or get them to lyse, that's spelled Lyse, and that means self-destruct, then if somebody hacked into the system and they were able to, cause the lysing or destruction of cells that you need, then by way of this technology, merely misapplying it, you could start, deleting pieces of organs that you need to function. So I think the hacking factor of this whole thing is really pretty important. But I don't know. I'm generalizing, so I don't know.
One hand washes the other, brother.
Yeah, well, yeah. This is just such a big deal. It keeps coming back to me that it's an area that we just shouldn't be going into, because I don't think that we have sufficient wisdom and we don't have a sufficient consensus amongst all of the people and peoples of this earth versus those who are at the levers of extreme power and control and financing for us to be able to hold our own with it. I don't think we have that position right now. And I think we need to get it, or I think we're going to be entering into a world that's more than just brave and new. It's downright scary to me. And I'm not a fearmonger. We try to do this show for entertainment purposes, and I don't know.
You know what I see right there with the magnets and the fields on that guy's brain, the head? I see nano-sized handcuffs, chains that will never go away and that will likely at some point get sophisticated enough to be passed down to offspring, provided that you can have offspring, that you're not sterilized. And then the other thing I see with that is something that could radically enhance what we would understand as retirement living. You spend your whole life working for the proverbial man, for somebody else, for most people, and then the best that you can get to potentially enjoy some component of your life is at the end of your life for a lot of people, at which time your body is, for the most part, used up. And so the potentials for a new type of renaissance to extend life and to extend quality of life, to allow for time to exist between multiple generations, more so than it is now. There's a beautiful renaissance that potentially exists with technologies like this to augment a decaying meat suit without looking at the meat suit like it's something dirty and bad, to appreciate a decaying meat suit as an opportunity to contribute to the species going forward in time, to first and foremost provide fellowship and counsel and mentorship to the young through families, so the old can take care of the young while the able-bodied are able to work. And the way most of the world works, and the United States doesn't, along with some other countries, we don't. We kick our old to death care facilities where they're medicated out while they're all of their life savings, all the value that individual's worked for their entire life goes to some corporate death panel instead of back to the family, because in our culture, we don't understand what it is to appreciate something other than ourself. Everything is focused on self. And I'm not saying everybody is selfish. What I'm saying is, when we're looking at the potentiality of what these systems are doing or can do or may do, it is the idea of releasing AI into the wild so that it is able to groove and like water on rocks, or like what water did to the Grand Canyon, literally shape and regroove and neurally engineer society, so that you have what propaganda has done for the last 100 years or longer, based on what you conceptualize as propaganda, which is simply nothing other than communication to people or the masses, and the manipulation of that information for some other purpose that isn't necessarily prima facie on its face. We're at the point now where technologies are so sophisticated that AI can be created as code that runs around on the internet and translates itself into biologic code through complex directed energy transducing systems that Nanotech allows basically any corporation or any government at this point to log in. So intellectual property is something that goes far beyond what you put to paper, so to speak, for yourself or for a corporation. Intellectual property, if you work for a corporation, arguably could be everything that goes through your brain, even on your own time. And in my view, fundamentally, that is a violation of the Fourth Amendment first. Secondarily, there's no way that corporations are going to stop with simply monitoring. They are going to want to maximize the return on their investment of their employees. So what that means is to provide stimuli that directs the conscious and the subconscious thought, right? The background processes, something similar to what a computer does in the background. You have this much available computer processing space, and your video stream takes up this much, and your Excel file that you're running takes up this much, and your antivirus takes up this much. Well, your brain works the same way. So if a corporation right, is going to view you as property and consider that your intellectual property while you're working on the problems that you are faced with at work to solve a problem, whatever it is, simple or large, doesn't matter. If you're working through that at home, the corporation would view that as intellectual property, right? So where does this barrier, where does the wall, where is the proverbial line in the sand drawn when access to intellectual property, when those lines are now blurred because we've created bidirectional systems to the nervous systems of the species? Where does that go? And the Internet Bill of Rights, going back to what I was saying earlier, the Internet Bill of Rights needs to be considered strongly. And then what needs to be considered first and foremost is who have been the loudest voices advocating for where we're at with the Internet Bill of Rights or the concept of internet regulation today. And what I submit to you is that the largest advocates for what is allowable over the internet are the largest violators and the greatest profiteers of what I have coined as P networks, private networks, personal networks, pedophile networks, presidential networks, preferred networks, P networks, all of the networks that work in the background that are pay to play for access. And I think intellectual property at this point goes far beyond what people put pen to paper. All that said, I hope Google and Microsoft and Amazon and Facebook and Twitter are listening.
I'm sure they are. And I'd like us to be able to illuminate and quantify as much of what they do that we possibly can for the benefit of everybody who has not been informed by those concerns, because you need to know. And, you know, these are for-profit and for-power businesses. They're not going to tell you anything that they're not forced to, that they don't have to. Everything that they do is to promote their business or their expansion plan. So user beware. No matter what you use a Google phone, beware. Use a search engine, beware. Whose benefit is it for? You've gotten me thinking a whole lot of philosophical thoughts. That could be the beginning of a really big conversation. Anyway, I have something else here, and I'm only going to just breeze through this really fast, because I think you might enjoy it more if you read it offline on your own time. So we'll put the link to it below in the show notes. But this just gives you a little bit of an idea. I think my big takeaway from this is in looking at the amount of research that really is being done in this whole area of quantifying and qualifying the operation of neurological centers. And of course, you know, most of what you hear about is always done with that famous mouse or rat. But it's certainly that you never would do any of this stuff with mice or rats if all you wanted to do was just learn how to, master the race of mice. It wouldn't be that. There's a different kind of race mastery involved here. And I think you all kind of know the game now. So the title of this is in the Atlantic. Neuroscientists discovered a phenomenon they can't explain. And I'll read a little bit of it, but then I'll summarize it for you also. Okay, these guys know that the brain is flexible, but not too flexible, that it rewires itself in the face of new experiences. And as we've, in the earlier part of the content of tonight's discussion, you see other ways in which the brain can be artificially rewired as well. So keeping all that in mind in the context of this, I'd like you to maybe pay attention to some of the specific manifestations that they talk about here and some of the centers of the brain that they specify are areas where some of this happens. So I'll read a little and then we'll talk, and then we'll be out of time. But, I think we'll leave a little bit of time to summarize the big takeaways from tonight's discussion toward the end. We got about 20 minutes left here for this. So The brain rewires itself. Simple explanation found in neuroscience textbooks is that specific groups of neurons reliably fire when the owner smells a rose or sees a sunset or hears a bell. These representations are patterns. Those patterns arise from, where was it? Yeah, they arise from this kind of wiring right here. That is exactly why those patterns arise. All right, that little wire between those two nerve cells. Okay, so these guys discovered something unexpected, which was that the brain seems to be able to rewire itself in some unpredictable ways. And I find it fascinating. It's only peripheral to our discussion, but it is nevertheless interesting. These scientists allowed mice to sniff the same odors over several days and weeks, recording the activity of the neurons, and I'm going to add in the specific neurons in one part of the brain, the piriform cortex. That is a brain region involved in identifying smells. So you can see they know what centers of the brain are associated with things right down to smell versus taste. That's the piriform cortex. At a given moment, each odor caused a distinctive group of neurons to fire in this region. So your next takeaway from that is they're able to image and observe quite precisely exactly which neurons were firing when the smell center was activated, and furthermore, with a specific same odor over several days and weeks. So this tells you where the science is at. Okay, going on. Some neurons stopped responding to the smells, but others started. And after a month, each group of neurons was almost completely different. So what this now implies is that they've been able to observe a kind of a handoff between pattern recognition and behavioral response from one little group of neurons to another group. So for you, the user of your brain, it might be seamless that your brain was rewiring itself, and that one whatever behavior or pattern, or maybe it's like a muscular coordinative activity that you have, may have been handed off to other nerve cells in your brain unbeknownst to you, because you've continued to be able to sharpen that pencil or ride that bicycle, or you've continually been able to recognize the smell of whatever it is that you smell. The neurons that represented the smell of an apple in May and those that represented the same smell in June were different. Fascinating. So, insight. The brain is continually rewiring itself. These things. So if we wonder where our ability to learn and our ability to be creative might come from, and what is it that made one group of neurons decide that they're going to be the ones that start smelling an apple? Like, how does this happen? The ingeniousness of the creation of all life in general, but the human brain, is utterly stupendous to me. And then that, and now tying into the previous part of the discussion, but at the same time getting back to the article, if you consider that by way of artificial means for outside purposes, we have researchers that are working on developing a kind of a fixed system, a network, in which the control is now no longer on the part of whatever it is that made the brain decide to rewire itself, but is now handled from the outside. Well, another little takeaway from this is this gives substance to the idea that the brain is indeed rewirable. And I guess the distinction that I'm making is where these guys are highlighting how the brain wires itself, but I'm attempting to highlight that you're going to be able to do that rewiring from outside. So these guys, they needed to develop surgical techniques for implanting electrodes into a mouse's brain and keeping them in place for many weeks. Only then could they be sure that the drift that they witnessed was really due to changes in the neurons and not small movements of the electrodes. Okay, so they're talking about their procedure. And then they're going to go through illustrating the rigorousness of their experimental procedures so that we know that their experimental results were valid. They showed that if a neuron in the cortex reacted to a specific smell, the odds that it will still do so after a month are just 1 in 15. At any one time, the same number of neurons fires in response to each odor, but the identity of the neurons changes. Another interesting little takeaway. So if you're going to process the smell of an apple, it's going to take X number of neurons to do it, to input it from the nose, from the olfactory sensors, to process it into some sort of a recognized pattern, and then to associate it with maybe a mental picture of an apple. All right. So that requires a kind of a finite and known number of neurons to do all that processing. Daily sniffs can slow the speed of that drift, okay, repetitive programming, but they don't eliminate it. And nor, bizarrely, does learning. If the mice associated a smell with a mild electric shock, the neurons representing that scent would still change, even though the mouse continued to avoid it. So that implies a second layer of complexity in terms of the plasticity or the programmability of the brain. Now we're going to move on to another section here. Well, it's part of the same thing. There have been hints of this for at least 15 years across many parts of the brain. Now we talk about another piece of it. The hippocampus helps animals navigate surroundings. I did not know this before I read this article. So it contains placement cells, neurons that selectively fire when the owner of the brain, enters a specific location. If you walk from your bed to your front door, and the different place cells will fire. But these preferences are also not fixed. So your ability to know how to get from your living room to your front door is something that you most of us pretty much remember it from day to day. But were we aware that which cells are handling that change? They change out, they shift around. It's like there's this big whole game going on in your mind where your brain cells are all kind of part of this general consortium, and they're all, in some way, they're all working together because the memory of how to get from the living room or dining room to the front door is preserved, but exactly who's doing it, who's responsible for that knowing, it changes. Fascinating, isn't it? Now, what if you were artificially to take all of this immensely ingenious way of life at the neurological level and control it manually from outside with a computer, and you would fix it and lock it in, that if you're going to know how to get from your living room to your front door, we're going to put in something that makes it so that it's always a fixed part of the brain in that hippocampus that always keeps that. And it's not going to be plastic anymore. It's going to be fixed and under external control. And to antagonize that point, I would say, isn't there something beautiful about the idea that the brain has such neuroplasticity and that it adapts and it adjusts and it's like it changes and it grows and it learns and it has creativity and it's got, somewhere in there between your heart and the extended consciousness, it's got your spiritual self as well. Isn't that amazing? Think of this. All right. So in another experiment, Laura Driscoll, a neuroscientist who's now at Stanford, placed mice in a T-shaped maze and trained them to go either left or right. That task depends on the posterior parietal cortex, a brain region involved with spatial reasoning. This is another region of the brain that they know, and this is in mice only, and this is for entertainment purposes only. Driscoll and her colleagues found that activity in this area also changed. It drifted. The neurons that fired when the mice ran the maze gradually changed, even though the rodents remained able to navigate the maze. Are you finding this fascinating, TMC? I am.
Well, it's all fine and well. I can show you the human translation to that if you want.
Well, all right. Let me see how much more there is, and I'm look at the time here. Yeah, sure. Yeah. Do you have anything that you want to illustrate, or would you like to expound verbally on it?
No, I'm going to take share from you.
Okay. Cool.
Okay, so this was published in 2016. It's been an ongoing endeavor, and it's what they call human bond communication, future wireless systems for human bond communication. It says that it's currently a vision, but it's expected to come true. And it's talking about, in this paper, exactly what some of the high-level interests are. And so what this talks about is a communication ecosystem that improves the quality of life by increasing comfort and the enrichment of the interactions and conditions of our everyday activities. In the near future, a general objective is likely to encompass the capability of the human being to communicate sensations by incorporating the 5 sensory features in messages and allowing a more expressive and holistic sensory information exchange through communication techniques. I'll abridge this a little more. This communication technology has enabled the acquisition and the transmission of sound, oral, optical, right, which is light, by their auditory and optical senses, right? So what does that mean? You have a camera and you have a microphone. You can transmit sound and light over the internet and share FaceTime with somebody, right?
Sure.
It says here, on the contrary, the possibility to integrate the olfactory, the gustatory, which is the sense of taste, and tactile, which is pulse perturbations or nerve impulses, right? Sensory features in the communication is still far from a reality. Now, this is what they're saying, right? Is that you cannot yet transmit smell, taste, and touch over the internet, but I beg to differ. Nonetheless, human bond communication is recently defined as a concept that incorporates, this is why we're reading this paper slowly, this new technology known as human bond communication incorporates smell, taste, and touch sensations, pursuing a more human sentiment-centric communication for future networks. Now, what would people do if they had access to your brain and all 5 of your senses? What would a back massage feel like over the internet? What would a hug feel like over the internet? What would a massaging of the brain could
be made to feel completely real?
Yes. Especially when you overlay augmented reality systems. And if you start looking at patents, particularly in Amazon, comes to mind, Amazon patent, where they have a device that's in the corner of the wall and the ceiling at some point in your room that has a projector or 2 on them. And this is just a rudimentary design so that it can project light. So you have a screen to look at, a projector. More advanced versions would be multiple devices all around the room to do something like do a hologram in your living room. And then it has ultrasound transmitters and receivers, which do things like provide artificial sensations at a very, very basic level, in addition to sensing where you are in the room. These technologies have been deployed for a very, very, very long time and currently exist in things like a Microsoft Xbox. Just one example. Going back to human bond communication, right? It's looking to incorporate not only sound and sight, but also to be able to transmit smell, taste, and touch over the internet after it's extracted it from your nervous system, transmitting it to somebody else. And what it talks about here is the main features of human bond communication, as well as describing flexible architectures that can be adopted for future wireless systems. Upcoming 5G standards, wireless body area networks, also known as personal networks, going back to the P networks that might use stuff like this. What they want to talk about here is how to bring this stuff online, how to mainline it, how beam forming and how sharing the network so that multiple beams from different antenna substrates and antennas antenna masts, if you will, are able to, through a cloud network, basically pick a point of interest and send and receive stimulations to what they call senducers. And so I'm totally speeding up along here, but what this talks about here, we'll go step by step. To achieve successful transmission of human bond information, meaning reading all 5 of your senses, putting them over the internet and putting them into somebody else. Sounds like some demon things to me, but anyway, this human bond communication via a communication medium must have a system that samples and interprets a physical subject into the 5 sense domains. So you can sample a person, you could also sample an animal, you could sample a plant. So what does this look like? A student in a not so pedophilic environment could potentially be looking at a tablet or a hologram on the desk that is something like a book, that when they flip the page, they're going through different plants in the forest, and they come across huckleberry, or they come across mulberry, or they come across mint, or they come across whatever, lemongrass. And as they are learning about these plants, they get the sensation of the texture in their hands. They get the sensation of what it would taste like. They get the sensation of what it would smell like. They perhaps in a military environment would get the sensation of what it's like to be gently poisoned by something that may be a plant that's useful, but only in certain applications if you really need it, like some hardcore plant medicine or some peyote or some sap that comes out of a tree, that if in a military environment you were training in a desk space, so to speak, or in a hologram room where you had an environment that you had a HoloLens on that Microsoft owns that puts augmented reality out into a blank space so that somebody can go through and pick through a virtual environment and learn about what's edible and not edible so you don't die. These technologies are amazing, but none of it's regulated beyond what brings your body temperature up due to a field exposure. It's basically it. It's the only thing that's regulating this stuff. And we're at the point now where nanotech allows for multiple modalities to stimulate a human organism and or to measure a human organism that is well within what is currently considered safe transmission levels. And we're not even talking about amplification technologies where you can have constructive wave interference so that it transmits at a legal transmissible level from a phone or from a tower. And because the waves reinforce each other at a particular distance, you can look this up. It's a projected electromagnetic energy gun. A PEG is what they call it. And what it does is it sends out no energy at a measurable level at the point of transmission. And when it reaches the point of interest, it's 41,000 times stronger than when it was transmitted. And this is just coming from 2 transmitters. Now, when you start looking at electromagnetics, and there are patents from Boeing that talk about sending 2 different frequencies simultaneously from a single transmitter. Now we can see what a 4 or a 5 or a 6 antenna standard in your phone, a 6 antenna transceiver device in your phone that has the potentiality to transmit more than one frequency simultaneously can do things like get way beyond what the legal levels are from the FCC.
Yes.
And that's just hardcore melt your brain or give you cancer because we don't like you. Anyway, back to human bond communication. It talks about senducers and what they call human bond sensorium and transposers. And really what this is sophisticated proprietary stuff that allows for the capturing and the transmission of human bond sensorium. And these things are simply wireless nodes that convert biological signals into digital ones and zeros and then are transmitted into another individual with what they call uniducers or senducers. And I'll send this out on Twitter so that you guys can look at it. But he talks about 5G in here and the benefits of it and why it's necessary and all this stuff, right? And what they're talking about here that's important is spectrum utilization, all spectra from cellular bands to visible light. So this is 5G, 6G. stuff, which means that the lights in your house are ultimately going to be part of the Internet of Things ecosystem. Go ahead.
So how much of 5G, in your pretty well-studied view, is about better field saturation versus better throughput, faster throughput? What is more important in that new technology that they're rolling out everywhere?
It's both. You need both. And what you're looking at here is minimum of 1 millisecond latency for remote robots, right? Or tactile internet applications, or 2 to 5 milliseconds for downloads, right? So what these are minimum standard requirements so that you can offer quality of service for PNETs, for private networks, or for commercial grade networks where this is how it'll get rolled out first. They'll say, cool, man, you got you augmented a little bit. Everything's cool. Well, guess what? Now, what we can do with your cell phone, we can translate the bacon, eggs, gravy, delicious, beautiful breakfast that exists on the Delta in California. Beautiful breakfast. I wish I could remember the name. It's delicious. Anyway, if I were to proverbially take a picture of that and send it to my buddy named Bob, and Bob gets the picture, and when Bob opens that picture and goes, damn, that's a delicious looking breakfast, Bob gets the essence in the back of his palate and in his taste, in his nose, the smell, what the eggs and the bacon and the gravy and the biscuits all would taste like in like the perfectly built bite. And for him to experience that, he pays a $20 a month subscription to Facebook, who then has access to his brain so that he's able to get these extra stimuli. Can you imagine if his proverbial spouse happened to be traveling to Hawaii for some Kona coffee, right? And she wanted to say, hi, I love you, and give him a little peck and maybe tickle him and tease him a little bit while he's working his ass off. Great. That'd be a wonderful feature to expand this idea of human communication. In order to do this without frying your brain, or without sending a pinch instead of a stroke, or a bite instead of a lick, right? You need to have 1 millisecond latency or 5 millisecond latency standards so that if you do make a mistake, you're able to make the corrections. It's like error correction for any other network transmission.
Yep. It's got to be quick.
Yeah. Mm-hmm. So
absolutely.
Anyway, it talks about localization. I'm going to show wireless body area networks. This document's really amazing. I mean, we could. Over this document. And what this is a great little piece here where it talks about a patient-centered environment where you have all these little tumors. I mean, little sensors, biosensors on you, and these little biosensors basically perform a distributed antenna system, distributed architecture system in your body or on your body that then talk to a single communicator, i.e. your home network, that's then transmitted to the rest of the world. And anyway.
Wireless body area network.
There you go. Wireless in-body implants, nanographene oxide, conductive proteins. You know that some of the proteins, what they've done is they've been able to measure these things, and they all have unique resonance structures based on how they fold. And so they don't all resonate the same way. And a single protein being different than another protein can have 2 or 3 different resonances, which then only excite a particular part of the protein because it's not a perfect sphere. So some very, very, very sophisticated open air experimentation is underway for your entertainment purposes only, that ultimately are going to do something like this, what you see on your screen today. And here's where this goes between the America Western 5G networks versus the China model. It's really very simple. What you see here is a 3G, 4G, Wi-Fi wireless sensor network. Okay. And in the middle, you've got a cell phone or a PDA. And what they call here is a wireless body area network coordinator, a hub. Just translate or change that out for software. That could be a Facebook app. That could be a YouTube app. That could be a Google app. It could be a Twitter app, Snapchat, email. It doesn't matter. It's software that provides access to the hardware on your device that remotely measures and interacts with your wireless body area network, up to and including implants or conductive or magnetic spike proteins. Going back to the Chinese model, the way that China is winning with 5G is offering a distributed system that is forwards and backwards compatible, so that you have countries that don't have the money or the infrastructure to go ahead and overhaul everything like they're trying to do in the US. And the rural broadband is going to be a hybridized conglomerate. Huawei and ZTE are already all over American networks. I mean, we've been infiltrated for 30 years in the telecom sector at a minimum.
At least.
All that being said, Huawei can offer 5G forwards, backwards compatibility to countries that don't have an evolved wireless network at pennies on the dollar, when compared to companies like Orange or AT&T or Verizon or whoever else that does business as some other company, an affiliate company, which is called a multinational corporation. When they go say, no, it's going to cost this much money, Huawei can go in and go, no, we can give you 5G. It'll be a modified 5G, and we'll control it with our AI systems, which offer optimization through something like device-to-device connectivity, which is a whole other discussion where one phone talks to another phone, and it doesn't need to use the cell network. So you can offer code out into the network, dump it into a phone, and have it bounce from phone to phone to phone to phone and never touch the network again, through what they call device-to-device or machine-to-machine communication. And that's where the AI optimization occurs through the radio antenna networks known as RATs or RANs. And these networks are all software controlled, and they create complex distributed antenna grid systems that have central command and control flexibility for imaging and for weapons-based applications. And I can show you things from DARPA, particularly their 5G testing that they did. And I think Florida won. It's their SC2 program is what's coming to mind. DARPA's SC Sierra Charlie 2 program, where they picked schools to ultimately run AI over a 5G network that they simulated with their own little supercomputer that they built. Right? And what they did was that they forced certain metrics to be achieved so that the end result allows for something like a military network to be assembled and established on any civilian network and not be detected and not be disrupted and take over priority, which means that the military communications that are technically not there but really are, kind of like, covert communications, they have priority over the network without setting off any alarms or sensors throughout the native infrastructure. And this is where China and the Western 5G, 6G networks are really in competition, is how to sense where the other AI is. And this is where we get into quantum internet applications and how the nanotechnology that's being deployed ultimately enables nanoscaled, quantum-based, wireless body area networks with in-body and on-body devices that are both nano, micro, and macro-based, headphones and watch, and phone being macro-based. Micro-based would be something like a connected jacket that is the partnership between Levi's and Google, Project Jacquard. And you can look up Google ATAP, ATAP, Alpha Tango, Alpha Papa, ATAP, and that is their R&D, one of their R&D departments, Google. And one of their sub-programs is Project Jacquard. So the micro applications of something like this would be weaving in conductive traces into clothing so that it creates a conductive mesh on a particular part of the body, like the forearm, or throughout the entire clothing apparel, so that you are wrapped in something that potentially provides neuromodulating therapy. I'm not saying all this is bad. What I'm saying is medical grade electrotherapeutic devices are being deployed, and most people have no idea what it does or what it is.
Exactly.
And it's coming out in macro, micro, and nano scale. Watch, headphones, telephones, conductive fabrics, ultimately going down to the nano scale, which is synthetic graphene oxide and paramagnetic nanoparticles and genetic information that allows for chimeric protein expressions in the body up to and including magnetic crystals.
Let me grab the share while you keep talking and keep on going. Yep.
I'm
right
done.
on your topic that you're on.
I think we should start with HBC. I got a couple of things on HBC next week.
Okay. Well, let me just pique your interest. By the way, DB, thanks for forwarding this link to me. You know, we're all a team, and it was amazing that what you gave me to read. So we're talking about stuff that's very small, nano-sized. Can you imagine something that's like a net, that's like, you know, like a fishing net for catching or grabbing or holding on to things, that is so small that it can be injected? You're looking at something extremely small here. All right. And how small? Okay. This polymer mesh can be embedded with dozens of nanoscale electronic devices. Just showing you that. So you're looking at something microscopic here. Now, TMC, go ahead. I'll just.
This is one iteration of Charles Lieber brain mesh stuff, and there are other groups that do this. But you can look up Lieber patents, and he has Harvard's written articles about this stuff, and it's really, really amazing technology. With this picture here, imagine this being assembled into this grid-like structure once it's been delivered into your body
in pieces. That's right.
In pieces, and then moved and migrated to the appropriate location. The brain is what they talk about in this article, but think about a smaller wrapping of this stuff around the three nerves that innervate the forearm and the fingers and the hand. There are three nerves there that exist, right? And so if you can wrap around those, you now have control of a hand. You can now read the muscle signals and the neural signals out of the forearm and the hand. And most of the way that the brain processes tactile muscular functions, there's a large percentage that is allocated to fingers and dexterity for humans. So if you can tap into that, which is what Apple and Fitbit already have done with their electrode and electromagnetic devices known as a smartwatch, you have a great deal of access to the brain.
Mm-hmm.
And in this case, they're showing injecting this directly into the brain and having it unfurl over time to cover a large part of the cortex in between the skull, where the cerebral spinal fluid is, on top of the brain itself. And then it has electrical conductivity through the cerebral spinal fluid, CSF fluid, as well as the different centers in the brain. So they could deposit this over a part of the motor cortex, over the visual cortex, or over whatever, and then start learning and understanding how the brain responds to stimuli, environmental stimuli or artificial stimuli, and then read that stuff. And when you can read that stuff and you can basically reverse engineer how those signals got to be what they are when they were measured, then you can start providing very targeted stimuli back. And
conveniently,
these patents exist from back in the 70s for doing this remotely from things like a satellite with electromagnetics. So what we're looking at here is not cutting edge. We're looking at very, very old technology that has very, very cool material sciences applied to it that allow for higher fidelity, a higher interface. But these technologies were thought of and perfected and deployed, albeit in low resolution, back in the 70s.
Wow.
Wirelessly with electromagnetics, modulating some brain function. And the programs have just been going on and on and on and getting more and more sophisticated. And they're mainlining this stuff into the public sphere through the institutions and through the fanfare so that people accept the idea of connecting their brains to the internet and trusting the very people who are censoring speech.
Fascinating. You got anything else you want to put up?
No.
Okay.
I think
Brave New World?
Yeah.
All right. So thoughts for next upcoming installment. What are you thinking? I want to continue going in this direction. I think that in various ways, this is going to be a multi-episode discussion. There are things that we aren't going to explicitly speak about here on our stream, but you know what they are, and we know that you know what they are, and now you know that we know what they are, and we won't mention them, but you know them, and it's really important what's coming and what's out there and what's deployed and what's built, and the level of the material science at what its capacity is now. All right, TMC. I think we ran out of time as usual.
This and that are most helpful. So more of this and that.